This is the main time we get to circle Mercury, available at the very front, decreasing the region our solar-based device lies. Mercury, a little uninhabited planet, is enclosed by a web realm, a pristine work of art, interest, and secret. At a simple look, nothing appears to be full-size about this planet, yet most recent examinations by NASA have found a couple of surprising disclosures around Mercury that no individual anticipated. The marvelous revelations in combination with records from the James Webb Telescope have sparked discussion in the scientific community, with many implying the possibility of ultramodern extraterrestrial species concealing inside the world. Amidst the turbulent discoveries and odd conspiracy theories, a new arrangement is emerging within the scientific community. It's the end-all strategy to strip Mercury's cutting-edge perspective, its overwhelming veil, and screen its dark secrets and strategies. Exactly what mind-blowing secrets and procedures have been determined around Mercury, and what current plans does the scientific network have for this mysterious cosmic neighbor? Be part of us in this video because the Webb telescope eventually saw what NASA was concealing on Mercury all along. Our sun system is more than just an inherent framework. The 8 planets that make up this cryptic ring gadget have enchanting skills. Despite planets like Jupiter and Mars taking the spotlight with their impressive significance, an intriguing planetary body that appears lost in the group is Mercury. It is the planet that lies at the very top of the list of ultramodern planets closest to the Sun. Its separation from the Sun is a mere 58 million kilometers compared to Earth's 150 million kilometers. Mercury is also very small in comparison to Earth, measuring an excellent 3,000 kilometers in diameter. Due to its small size and proximity to the Sun, Mercury is the speediest planet, completing its revolution around the Sun at an incredible speed of 47 kilometers per second. The planet finishes an aggregate rotation in just 59 days. In other words, a year on Mercury is only 88 days. Mercury's short period and rapid speed are just a couple of its dazzling capacities. From a distance, it even appears like a bearable planet. The little planet has always been intriguing to the logical community, but for some reason, it hasn't garnered as much interest as its cosmic neighbors. The essential recorded observation of Mercury dates back to 265 BC with early astronomers like Zupus studying the world. However, all the scientific community had in these early times were pieces and fragments of data, as all their studies were achieved using inadequate scientific gadgets and old telescopes. It was only in the 1960s that genuine, unmistakable reality about Mercury came to light thanks to the efforts of NASA. A few years ago, NASA revealed the first genuine photos of Mercury to the general public. These larger-than-life images confirmed Mercury as a divine exemplification of modern work of art, beauty, and intricacy. However, it didn't come easily. Despite plans and attempts to understand Mercury, researchers could only examine it briefly. Researchers struggle to keep an eye on Mercury unlike other planets due to its proximity to the Sun. The Sun's unforgiving beams and intense heat can harm optical instruments like telescopes when observing Mercury from too far. Thus, researchers can only look at the little planet for a moment at a time to avoid damage to their gadgets. Even the James Webb Telescope can't point directly at Mercury due to its closeness to the Sun. It's puzzling how this small nearby planet is harder to test than the more distant ones. The temperature and gravitational pull from the Sun make sending a probe to Mercury more like a suicide mission than a heavenly challenge. The probe needs to adapt to the temperature, environmental factors, and gravitational pull, or it will fail. You might be surprised to learn that Mercury orbits the Sun at a whopping pace of 30 meters per second. This time-breaking speed makes it the fastest circling planet in our solar system. This also presents a hard challenge for shuttles aiming to survey the planet or land on its ground. To date, significant space missions have targeted Mercury, including the Mariner 10 launched on November 3, 1973, and the Messenger launched on August 34. These missions were brainchild of NASA and are our primary sources of information about Mercury today. The Mariner 10 spacecraft accomplished 3 flybys, each revealing Mercury's cavity-ridden ground and shedding light on its intriguing region. The spacecraft was equipped with telescopes, spectrometers, a magnetometer, and a plasma analyzer, enabling NASA to gather extensive records from Mariner's journey to Mercury. As progress would have it, the probe gradually found its way to the little fast planet. As Mariner 10 approached Mercury, researchers were astounded by the turbulent floor of the planet, which was ridden with numerous cavities and ridges similar to our moon. The photos from Mariner were mind-blowing as Mercury turned out to be unlike what experts had expected. Besides the rugged planetary floor, the probe also detected a tilted magnetic field and an enormous core. In all, Mariner dominated with twin 700 images of Mercury, giving researchers a unique and astounding view of the captivating landscape. The second flyby of Mariner occurred on September 21, 1974, during which it captured the southern polar region of the planet. The ultimate flyby took place on March 16, 1975, after which the probe stopped sending signals to Earth. Later examinations found that the spacecraft had exhausted its fuel supply, rendering it incapable of making further rounds. The superlative contributions of Mariner 10 were endured 30 years later when NASA's Messenger took over the mission to the nearby planet. Unlike its predecessor, Messenger did not conduct a flyby but rather orbited the planet, allowing researchers to gather more empowered and intriguing data about Mercury. Equipped with advanced instruments, Messenger made 3 circles around Mercury, taking around 200,000 images of the planet. These images were significant because they highlighted every side of the planet. During the mission, the probe entered the planet's orbit, flying about 250 kilometers above the surface. This proximity enabled the probe to capture images of both the light and dark parts of Mercury. By digging deep into the images and comparing them with data from the spacecraft, researchers determined that our small planetary neighbor had peculiarly high concentrations of calcium. The planet's magnetic field also appeared abnormally distorted, being stronger in the northern regions. This peculiar pattern puzzled researchers for years until further analysis revealed more about Mercury's unusual magnetic field. Mercury's strange and unique magnetic field is a lessening aspect of how the planet forms at its core. Magnetic fields on planets are generated by reactions occurring in their centers. For example, Earth's core is comprised of fluid iron, and the inner layer of this iron transitions to solid. The continuous solidification of fluid iron inside the core causes a magnetic field. In other words, more solid iron is being formed in our planet's core as fluid iron cools and solidifies. When solid iron forms, it interacts with the surrounding liquid iron. As this occurs, the Earth rotates around its axis, creating a contemporary structure. Eventually, strong electric currents are generated, producing a vast magnetic field that extends into space. This is the modern process for generating the Earth's magnetic field, resembling a snowstorm where the snow symbolizes the zenith of contemporary phenomena. Mercury's magnetic field studies reveal that iron precipitation fuels its magnetic field. This discovery, backed by NASA's Messenger mission, led researchers to believe that planets have multiple ways to generate magnetic fields. Despite Mercury and Earth having similar core elements like sulfur and iron, their differing magnetic fields result from significant variations. The differences between Earth and Mercury extend beyond their magnetic fields. For instance, Mercury experiences extreme temperature fluctuations, soaring above 430 degrees Celsius during the day and plummeting to minus 170 degrees Celsius at night. This is due to Mercury's lack of atmosphere. Unlike Earth, which has a thin exosphere created by meteoroid impacts and solar winds, researchers believe Mercury's intense heat prevents the formation of a stable atmosphere, causing any atmospheric components to quickly dissipate into space. As a result, the side of Mercury facing the Sun endures severe heat, while the opposite side remains extremely cold. 1 Mercurian day equals 1.176 Earth days, meaning Mercury is bombarded with intense sunlight for prolonged periods, causing drastic temperature changes. The extreme temperatures and lack of atmosphere have led scientists to speculate about the potential for life on Mercury. While the harsh conditions might make it seem uninhabitable, certain features suggest otherwise. The planet's surface, much like the Moon's, is covered with impact craters, some of which exhibit intriguing shapes. This has led to speculation about possible extraterrestrial bases, though no evidence supports this. NASA's Messenger mission revealed numerous craters, fissures, ridges, and possible volcanic activity, suggesting ongoing geological processes. Moreover, The discovery of ice water deposits in Mercury's polar craters has fueled further speculation. A study by the Planetary Research Institute confirmed that the North Pole might have conditions suitable for liquid water beneath the surface. This conclusion was drawn from recent photos taken by the MESSENGER probe, which showed ice sheets containing potentially life-supporting compounds. Despite Mercury's proximity to the Sun, scientists believe there is a possibility of finding extraterrestrial life if we dig deep enough. One of MESSENGER's significant achievements was mapping Mercury's surface, revealing its geological composition. The planet's crust consists of 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium, with surprisingly high sulfur levels but low iron content. This unique composition sets Mercury apart from other planets, typically richer in iron. This distinction has piqued scientific interest in Mercury's geology. Recently, scientists discovered a dusty ring around Mercury, sparking debates. Traditionally, only larger planets like Jupiter and Saturn are known to have rings. Jupiter's faint rings were first detected by Voyager 1 in 1979, while Saturn's prominent rings are visible from Earth. Composed of water ice and rocky material, these rings likely formed during the early solar system's history, with Saturn and Jupiter's massive gravitational fields attracting cosmic debris. However, Mercury, being much smaller, having a dust ring raises questions. Researchers speculate that this ring might have formed from meteoroid impacts that launched debris into orbit. Dr. Peter P., a NASA research associate, suggests that Mercury's lack of a substantial atmosphere allows frequent collisions with space objects, contributing to its dust ring. Other experts agree that continuous meteor impacts and other disturbances likely shaped Mercury's small size and thin mantle. Overall, the intricate features and phenomena observed on Mercury continue to intrigue scientists, prompting further exploration and study of this mysterious planet. A large number of people believe that there is an open door to contemporary-day ways of life on Mercury. This belief has sparked questions such as what if Mercury is truly inhabitable, and assuming it is, what kinds of life forms might exist on the planet? To date, the surface of contemporary Mercury has proven to be very intriguing. Much like our Moon, the planet appears to have numerous impact craters, and the Moon has long been associated with debates and conspiracy theories involving extraterrestrial creatures. These theories are fueled by the Moon's many famous craters, some of which take on perplexing shapes like arches. Although there is no evidence of extraterrestrial moon bases, many have started to point fingers at Mercury, suggesting the presence of advanced species there. While impact craters are generally the result of space rocks, it is not impossible that some could be caused by rockets. For instance, NASA's MESSENGER probe caused a large crater when it collided with Mercury's surface on April 30, 2015. Today, Mercury's surface features countless craters, ridges, and even evidence of volcanic eruptions. This raises the question of whether some of these craters might be new, created by similar extraterrestrial spacecraft or activities. Various intriguing aspects of Mercury have also led to conspiracy theories, such as the discovery of ice water deposits in the craters at the planet's north and south poles. Recently, a study from the Planetary Science Institute confirmed that Mercury's north pole could have conditions suitable for liquid water. These areas resemble Earth's environments but are hidden beneath Mercury's surface. This conclusion was drawn from the latest images from NASA's MESSENGER probe, which were used to create a map showing that certain ice sheets on the planet contain hazardous compounds that could support modern biolife. Despite Mercury's harsh environment and proximity to the Sun, some experts believe there could be a chance of extraterrestrial creatures or advanced biomes existing on Mercury if we dig deep enough. One of the most significant achievements of NASA's MESSENGER probe was mapping Mercury's surface, capturing all the craters and basins. This gave scientists at NASA an opportunity to study the planet's geology in detail. The probe also revealed Mercury's composition, which includes 46% of oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. Additionally, researchers found that Mercury has a surprisingly high abundance of sulfur but very little iron, which is unusual compared to other planets in our solar system. This discovery set Mercury apart as a unique planet, differing significantly from the rest of the planets. which are typically more abundant in iron. Recently, scientists noticed something extraordinary about Mercury. It has a dusty ring around it. This discovery sparked discussions in the scientific community as Mercury seemed too small to have a planetary ring. In our solar system, only Jupiter and Saturn are known for their rings. Jupiter's rings are faint and were first detected in 1979 by the Voyager 1 spacecraft, while Saturn has a well-defined ring system visible from Earth. Saturn's rings consist of billions of small particles, including water ice and rocky material. Researchers believe that these rings formed during the early stages of our solar system. Given Saturn's massive size, about 95 times the width of Earth, it managed to attract a large number of small rocks and debris to form its rings. Jupiter, nearly 12 times the diameter of Earth, also attracted around 95 moons and formed its own ring system due to their immense gravitational pull. However, this raises the question of how Mercury, the smallest planet in our solar system, could form its own rings. Mercury's dusty ring is about 9 million miles wide. Researchers are still unsure how these rings formed, but many speculate that they might result from media impacts. A team of researchers led by Dr. Peter P., a research associate at NASA, suggested that this hypothesis is likely accurate. He explained that it is common for celestial objects to collide with planets like Mercury, which lack a significant atmosphere, potentially launching debris that eventually formed the visible ring. Many experts in the scientific community agree, adding that continuous weathering of Mercury's surface by media impacts and other events could have contributed to its small size and thin mantle.